Good morning, everyone, and welcome. So today we're going to dive into one of the most powerful, most practical applications of mathematics in the entire business world. We're talking about using differential calculus to make optimal strategic decisions. Now, I know what you might be thinking. Calculus, right? But trust me, this isn't just some abstract theory from a textbook. This is the mathematical engine that drives really critical decisions in pricing, in production, and ultimately in profit. So let's get started.
So let me just start by asking you this question. How do you find the perfect price for a product? Think about it for a second. If you price it too low, sure, you might sell a lot, but you're leaving money on the table with every single sale. On the other hand, if you price it too high, you could drive your customers away, and your demand just plummets. So, where's that sweet spot, that optimal point? How does a company, any company, figure out the one single price that's going to generate the absolute maximum profit? This is the fundamental question we're going to answer today.
All right, to make this concept really concrete, we're going to work through a case study together. I want you to imagine that we're consultants, and a new coffee shop right here on campus has just hired us. They've created this amazing signature latte, and they've come to us with a question that sounds simple, but is actually really complex. What price should they charge to maximize their daily profit? Not just sales, but profit. This is the core business dilemma we're going to solve.
Now, the first instinct for so many new entrepreneurs, and this is a classic, sometimes fatal mistake, is to focus only on maximizing revenue. They just want to sell as many lattes as they possibly can. They see those high sales numbers as a sign of success. But our goal, as strategic thinkers, as business analysts, is not to maximize revenue. Our goal is to maximize profit. And profit, as you see here, is the difference between your total revenue, all the money coming in, and your total cost, all the money going out. That gap, that difference, that is the lifeblood of any successful business.
So how in the world do we find the price that makes that gap, that profit, as big as possible? Well, for this, we need a very specific mathematical tool. And that tool is differentiation, a core concept from calculus. We're going to use it to find the very top, the absolute peak of what I like to call the profit hill, that one single point where our profit is at its maximum.
And I really want to emphasize, this is not just some academic exercise we do in a classroom. As our source material points out here, this is the bedrock of modern business strategy. I mean, think about it. Setting a price, managing inventory, figuring out the most efficient shipping routes, allocating an advertising budget. Business leaders are constantly setting up and solving these optimization problems. They are using the power of math to find that sweet spot of the highest possible return for the lowest possible cost. Okay, so let's formally define our tool. Differentiation is the process of finding what's called a function's derivative. So what's a derivative? Well, in simple terms, it's a new function that tells us the instantaneous rate of change, or you can just think of it as the slope, of our original function at any single point. It's like you're zooming in on a curve so much that it starts to look like a straight line. The derivative gives you the slope of that line. It tells you exactly how fast something is changing and in which direction at one specific moment. And this is where that formal definition becomes really intuitive. I want you to imagine our profit function is this hill. As we start increasing the price from zero, our profit starts to climb, right? The slope is positive, we're going uphill. But eventually, we reach a point where if we keep raising the price, our profit actually starts to go down. The slope becomes negative. But right at the very top, at the absolute peak of that hill, for just one brief perfect moment, the ground is completely flat. The slope is zero. That is the maximum point we are looking for, and differentiation is the tool that lets us find that exact spot.
All right, so before we can use our tool, we have to build the thing we're going to use it on. This is such a crucial step for any business analyst or manager. You have to be able to translate a real-world business situation into a mathematical model. This is where the art of business really meets the science of mathematics. We need to create an equation, a function, that accurately represents our coffee shop's entire profit structure.
And we're going to build this model very systematically, step by step. First, we need a demand function. That's just an equation that predicts how many lattes we think we're going to sell at any given price. Next, we use that to build a revenue function, which is simply the price multiplied by the number of lattes we sell. After that, we have to build a cost function. And this has to include everything, our fixed costs, like rent that we pay no matter what, and our variable costs, like the milk and coffee for each individual latte. And then finally, we'll combine all of these pieces to create our single, all-important profit function. And this is what that function looks like conceptually. P of x, which is just profit as a function of our price x, equals our revenue minus our total costs.
So for our case study, let's put some numbers on this. Let's say our market research gave us a simple linear demand function. The quantity we'll sell is 350 minus 40 times the price. And let's also say our variable cost for each latte is $2.75, and our daily fixed costs, like rent and utilities, are $100. Just like that, our entire complex business problem is now captured in a single powerful equation. This is the mathematical formula for our profit hill. Okay, everyone. The model is built, our tools are ready, now it's time to apply calculus and actually solve this problem. We are now going to find the precise, optimal price for our campus coffee shop's signature latte. This is the moment where all the theory we've been talking about becomes a practical, actionable business strategy. So, just to be perfectly clear about our objective, we are about to find the absolute peak of our profit function, and that peak represents the maximum possible daily profit our coffee shop can make.
And the key, the mathematical secret, as we've discussed, is this principle right here. At that maximum point, the rate of change is 0. So our process is clear. 1, we take the derivative of our profit function. 2, we set that derivative equal to 0. 3, we solve for the price, x. Now our profit function, p of x, simplifies down to negative 40x squared plus 460x minus $972.50. Using the power rule from calculus, the derivative, p prime of x, is negative 80x plus 460. We set that equal to 0, and we solve for x.
And after we perform that calculation, after solving negative 80x plus 460 equals 0, we get our answer. The single best price is $5.75. And I want you to appreciate what this is. This isn't a guess. It's not based on a gut feeling or intuition. This is the mathematically proven optimal price that is derived directly from our business model.
Now, arriving at this number, $5.75, that is a critical achievement, but it's only half the job. For you, as a future business leader or analyst, the real skill, the thing that gets you promoted, is what comes next. Interpreting this result and translating it back into a confident, data-driven business decision. What does $5.75 really mean for our strategy?
Let's really see this in action, okay? Imagine the manager's best guess. Just their intuition led them to a nice, round number, $5. At that price, our model predicts they'd sell 150 lattes for a daily profit of $300. And you know what? That's not bad. But now, look at our optimized strategy. At $5.75, we actually sell fewer lattes, only 120. Now, this is the point where a lot of managers get nervous. They see sales volume going down. But look at the bottom line. The daily profit is now $350. Why? It's because the extra 75 cents of profit margin on each of those 120 lattes far outweighs the profit we lost from the 30 people who didn't buy. This is the power of optimization. We generated $50 more in pure profit every single day. That's over $18,000 a year by selling fewer items at a higher, mathematically determined price.
And doing this type of analysis helps us avoid some really common strategic traps. The first one, as we just saw, is focusing only on sales volume. Big mistake. The second is ignoring that cost can change. We used a simple model, but in the real world, the cost to make the 100th latte might be different than the 10th. That's a concept called marginal cost. It's also absolutely crucial that your demand model is built on good data, not just wild guesses. Remember, a flawed model will just give you a very precise but very wrong answer. And finally, you have to remember that the market is always changing. Your perfect price today might be totally wrong in 6 months when a competitor opens up next door. You have to constantly reevaluate your models with fresh data. So we've spent this whole time focused on a single price for a single product. It's a pretty contained problem, but I want to leave you with this question to think about. What if you applied this exact same way of thinking, building a model and finding the optimum point, to an entire global supply chain, to manufacturing, to logistics, to inventory, across dozens of countries and thousands of products? The complexity grows exponentially, of course, but the fundamental principle, using differentiation to find the optimal solution, that remains one of the most powerful and versatile tools in all of business. Understanding this is absolutely key to your future as strategic decision makers. That concludes our lecture for today.